Hello students, welcome to Saurav sir's classes. Welcome to Saurav sir's classes. In our today's video, we are going to discuss question number 16. Question number 16 of IIT JAM 2019 paper. So this is for all IIT JAM aspirants. Recent paper 2019 papers, question number 16. We are going to solve question number 16. So everyone open your question paper and follow question number 16. So let us discuss what question number 16 is. So now we are moving to question number 16. So let me read out the question. So the question is now before your screen, and the question goes something like this. So the question goes is the function. So we are given a function fxy equal to x cube plus 2xy plus y cube. It has a saddle point at what? 0 0, minus 2 minus 2 by minus 2 by 3 minus 2 by 3 minus 3 by 2 minus 3 by 2, or is it minus 1 minus 1? So we have got four options. We have got a function that is equal to x cube plus 2xy plus y cube. So we need to find that where is the saddle point. So first let me discuss what is a saddle point. So now I am going to discuss the theory part here first, that is what is a saddle point. So in mathematics, a saddle point is a point on the surface of the graph of a function where the slopes, so slopes is basically derivatives, so let me write derivatives in brackets. So where the slopes in orthogonal directions are all zero. That is the critical point, we say in mathematical terms. The terminology is critical point, but which is not a local extremum of the function. So this is the saddle point. So the saddle point is the point on the surface of the graph of any function where the slope in the orthogonal directions is 0. So this is the thing we need to consider, and we need to continue solving. So we have got a function. We have got four options, among which only one option is going to be correct. Now we are going to solve this. This is a very simple question, okay? Very simple question which has came in IIT JAM. So this is a bumper question for all the aspirants in this year. So we are now moving towards the solution part of this question. Solution. Okay, so the function is given to be fxy equal to x cube plus 2xy plus y cube. So this function is given. Now we have to find the derivative. So first, now we are differentiating this with respect to x, that is fx. So we are differentiating this function with respect to x. Okay, so what will be it? It will be d by dx of this function fxy, which follows that d by dx of x cube plus 2xy plus y cube. So we have to differentiate this. Now differentiating this, it will be 3x square plus 2y square. So plus 2y, it should be equal to 0, because in saddle point we know that fx or the first derivative should be equal to 0. So we have equated it with equal to 0. Now what will the value of y? Taking this to this hand side, it will be 3 by 2 x squared. So this is y. We are getting the value of y here. Now we have achieved one part of this section. Now moving to the second part. Now fxy was given to be x cube plus 2xy plus y cube. Okay, now let us do f of y. Okay, so it will be 2x plus 3y square, isn't it? Step follows simply. Fy is nothing but d by dy of f of xy, that is nothing but d of dy of the original function, that is x cube plus 2xy plus y cube. Okay, 2x plus 3y square. And if y should also be equal to 0, for if we need to find the saddle point at the critical point, for critical point we need to put fx equal to 0 and fy equal to 0, as I have mentioned in the definition of saddle point, that it should be 0, that is all the derivatives should be 0. Okay, so moving on. We have got fy equal to 0, fx equal to 0, and we've got a value of y. Now putting fy equal to 0, we will get 2x plus 3y square equal to 0. So x would be minus 3 by 2 y square. Okay, so we have got the value of y, we have got the value of x. Okay, so now it can be written as 2x plus 3 of 9 by 4 x to the power 4 equal to 0, which follows 8x plus 27x to the power 4 equal to 0. Or we can write, if we take x common, 8 plus 27 x cube equal to 0. Or we can write x 8 plus 3x whole cube equal to 0. So basically either x equal to 0 or it is minus 2 by 3. Now going back to the space provided here. Now see, at x and y both equal to 0, suppose x equal to y equal to 0, xy would be 0 0, that is at origin, simple as it is. So x would be equal to minus 2 by 3 and y would be at equal to minus 2 by 3 as well. So the xy which we are getting is at minus 2 by 3 and minus 2 by 3. Okay, now to get the saddle point, it is not yet over. Now we need to find this saddle point. Okay, we need to take the second derivative as well. So fx we have got, now we are doing fxx. fxx would be 6x. We will be doing fxy. So fxy would be 2. We will be doing fyy, that would be 6y. Now at 0 0, at 0 0, f of xx into f of yy minus f, this is our second order condition, if you can remember in our math eco problem as well, whole square is equal to 0 minus 4, that is minus 4 greater than 0. Since the discriminant is minus 4, then this point is called the saddle point. So at where we are getting discriminant greater than -4, we are getting at 0 and 0. Okay, so at 0 0 we are getting, so the right option will be, going back to the question, so at 0 0, that is at here we are getting the value of discriminant saddle point, we are getting saddle point. So the correct option will be, see, the first option is 0 0, so this will be our right option. So option A is correct. Now if you have any doubt regarding this explanation, this topic which I just discussed it here, the saddle point, any doubt regarding saddle point concepts of anything, then you can call us anytime at this number 9836793076. You can either call us or you can WhatsApp us anything, or you can visit our website as well. We have a website. For further details, you can visit www.sauravsirclasses.com. This is our website. You can visit this website anytime for further details. And if you like this video, then thank you a lot, students.